Yeah, just... well, I met Mike, 17 years ago on some LISA conference, about the same conference I met John. But I met Mike in a completely different way. He was teaching a class about documentation, and within that class, he was like throwing cookies, Australian cookies, onto the audience. Tim Tams.
Tim Tams.
So he's the Tim Tam man, and he explained me that he would automate that. So this talks about automation, and apparently he reappeared somewhere in Europe, being Amsterdam, and we got together, and I said, give a talk about your subject on the NLUUG, and that became not a talk about Tim Tams, it became a talk about saving endangered species. So, go ahead, Mike.
Cool. Goedemiddag. Mijn Nederlands is slecht. Dus this lezen is in Engels. Thank you and welcome. There will be no Tim Tams. It's really hard to export them from Australia in the quantities that I used to export them to the United States, which was generally 2 suitcases and the person at customs saying, "Do you have anything to declare?" When I was talking with Rudy about submitting a proposal for this conference, it occurred to me that the audience here is actually really, really challenging to have a good talk, to prepare a good talk for, because you already understand how important it is to have open systems, right? You already get that. And I can't really talk to you about, focusing on open source as something new because, you already get that. So I spent a lot of time trying to figure out a topic for a talk. And I decided, I'm going to have to do something that I can actually talk about, which is probably going to be automation and configuration management systems. All right, that's a good place to go. What topic, though, specifically? And I started going through topics, and I tried one topic and started writing a class to at least get an idea for the proposal. Do a little proof of concept, refine the proposal, submit it. And I tried one and I wasn't happy, so I tried another one, and that didn't help. And I tried a third one, and that didn't help either. And what I realized was that what I was trying to do is something that we do every day at work. Right? We try to solve one problem, fail, or maybe succeed a little bit, and get closer to the real problem that we're actually trying to solve. And then I thought about this a little bit more, and I tried to just distill it down to one thing that I could talk about, one thing that I could give you to take away. And I realized that I just created a new problem. So I decided that the best thing to do, the best thing I could do, was to not give you a takeaway like, use this tool, but to give you questions to take away. I want you to leave today's talk with questions. Okay? Philosophy, yes. The Socratic method, for those of you who have studied philosophy. I want you to leave with questions. Okay, that was the topic. Great. Now, guess what happened next? Which questions do I want you to take away? And I thought about 20 years of teaching automation and systems and config management and operations. And I thought about the questions that I get pretty much every time I teach. The first question is, well, where do I start? I have a lot of developers or system administrators who have come into the profession from different areas, and they know how to script. they know how to code, they know how to build machines, but they want to automate, they want to do this better, and they want to know where to start. That's question one, is where do I start? Question two is what should I do next? Well, it turns out it's actually the same question. All that's different is where you're starting from. For the first question, it's greenfields. For the second question, it's brownfields. Do those terms translate here? Yeah? Greenfields, nothing constraining you. Brownfields, constrained by not being able to break things, hopefully. The next question is, well, I've been automating for 2 years or 5 years. How can I do this better? It's the same question again, just a different starting point. Maybe different tools now. Right? It's about development, about maturity, and we'll see that in a moment. The last question is, well, okay, what tools should I use? All right, so expectation management again. This is not a talk about tools. This is a talk about automation decisions, with maybe one or two exceptions. Who is a VI user? Excellent. Put your hands down. Could all the Emacs users put their hands up? Both of you can leave. All right, it'll make the rest of this talk a lot easier. Okay. So there's also an implied question here. And the implied question is, well, what is automation? I mean, we kind of have a feel for it, but when you start to talk to people about automation, the first thing that tends to pop into their mind is that automation is about removing people. Now, that's obviously a little bit negative, but it's also not correct. There is a great deal of automation that takes place where the purpose is simply not to remove people. It's to improve a process. Right? In fact, it turns out that automation is just a form of optimization. We have something, we want to make it better according to some measure. How do we go about doing that? Removing people is just one possibility, and it's an outcome. It's actually not the driver, right, if we look at it honestly. Now, I'm going to be very clear here. I know that automation can reduce the number of jobs that are out there, but being as objective as I can, that's going to happen anyway. Okay? That said, it can improve productivity and it can make things safer for people if we do automation correctly. It can also make things dangerous for people, but we won't go there just yet. Okay, so automation is optimization. That means it has exactly the same advantages and exactly the same disadvantages that general automation does, and we have to go about it in the same way. How do you optimize a piece of code? Well, the first thing you do is you figure out what you want to optimize for, and then you start measuring. And then you target those measurements. And you measure again and see if you've got an improvement. All right? Fair statement, do you think? Would anyone like to challenge me on it? I like interaction. Okay. Second realization is that automation is a fundamental part of the way that we work, of our jobs here today. Sysadmins, raise hand. Okay, excellent. This is how sysadmins think of automation. How many people have this t-shirt? I will replace you with a tiny little shell script. Yeah. Okay. Perl? No. Developers, raise hands. Everyone should be raising their hands as a developer or a sysadmin. You develop, you just don't write applications per se. All right, we automate all the time. APIs wrap our automation tasks. Right? We use Swagger to generate code so that we don't have to type code out. These are standard techniques that we apply today, and they're just automation. Anyone here a professional tester? No? Oh, well, then I don't need to talk about testing. But you all know that testing is and should be automated for reproducibility, for laziness, for consistency. Right? These are all reasons to automate. And I'm going to repeat myself later in the class, right? But that's just reinforcement. I'm automating your learning at that point, or at least trying to. And people who work in what they identify as DevOps have a mantra: automate all the things, automate all the things, automate all the things. We can't extract automation out of our daily lives as technical practitioners. Okay, we just can't escape it. And honestly, whoa, it's missing the image. Damn it. Image of coffee machine making coffee so that you don't have to grind the coffee, and very disappointing. Sorry about that. Okay, so these are all the wonderful good things about automation. However, not all automation is desirable, let's be fair. I have to be credit for this robot to Simone Gertz, who identifies herself as the shitty queen of robotics. Absolutely amazing engineer.
Can you use the other side as well?
Sorry?
Can you use the other side?
I don't know. Would you like to be a test subject? Okay. So not all automation is desirable, and let's be honest again, not all automation is effective. Okay. I was really worried this wasn't going to translate to Dutch. So this is a talk about the types of thought processes we should go through when we're automating. A lot of it will be targeted, or obviously targeted at beginners, but I want you to go away with questions. So what I would like you to do is try to throw away all your knowledge. Come at this from the point of view of just being a beginner again. Right? Try to refresh your understanding. This is a personal position. Again, there will be beer after this talk, and I'm happy to discuss with people after at least one drink. We've been doing things the same way for so long that we've forgotten how to ask, why are we doing this, and can we do it better? Have you all heard the expression cargo culting? It's where you make an association, or you get so used to doing something in a particular way that you have an expectation of when you do it that way, it's always going to be the same. It's battle tested. It worked before, it'll work again. It'll keep working. It's reliable because of that, and I can rely on it, and I'm not going to get in trouble by doing the same thing over and over and over again. And that's often true, but not always. Not always. So, who would agree that automation is about time saving? Hands high. Don't be shy. Yet. Okay. This is an XKCD cartoon. Some of you may have seen it. And what this shows us is, it's a guide. It tries to give us an indication of how much time we can spend on a task that we're optimizing before the amount of time that we have spent is more than we'd save over 5 years. Okay? So in the easy case, which isn't up here, if you do this one task every 5 years and it takes you 1 day, then it's pretty clear that you could, if you could make it faster, you could spend up to a day before you're at the break-even point. Does that make sense? Okay, awesome. So, first of all, it is across 5 years. How many people plan their automation to last 5 years? Excellent, correct. Now, I was very particular in my choice of words. I said, how many people plan their automation to last 5 years? Okay, the systems people amongst you, what do you think of the two words temporary fix? Correct. Yeah. Unplanned 5-year change. Okay. Now, if you read this chart down, if I wanted, or if I was able to save 5 minutes on something, and I did that 5 times a day, or let's say daily, Over 5 years, I could save up to 6 days if I shave 5 minutes off. Up to 6 days of actual, I can spend that much time making this better before I start to have a negative payoff or loss. That's kind of cool. What else is interesting here? If I shave off 1 second of something that happens 50 times a day, I can save 1 day over 5 years. Not bad. You can read this table for yourselves. You have a reference. You can make this up in a spreadsheet. It's really easy. However, it's not really accurate, because it turns out that 1 day, if you perform the calculations, 1 day, so this guy here, is 1 day, literally, which is 24 hours. So these numbers are actually understated. The numbers that are in the middle here are understated. So if this says you could use 1 day, you could actually spend 3 work days optimizing something before you're at a loss point. Nice. 4 weeks, therefore, becomes 30 days, which becomes 90 work days, which is 18 work weeks, which is heading towards half a year. So there is value in spending time on automation. Also not included in this is opportunity cost. How much could I have done differently, or how much could I have spent elsewhere? But I couldn't because I was working on something else. I was running through this optimization problem, which stopped me working on something else for that much time. It's important because today's fast-moving world, if you spend 4 weeks on something that's not directly generating revenue, that's potentially going to be seen as a loss. So even though this is helpful, even though this is helpful, it is not absolute, and you need to think about what you're reading here. Now, obviously, when you automate some things, you may introduce new problems. So there's a net loss there. On the other hand, by automating very select and carefully chosen tasks, there may be a net gain. You may simplify so much else that it's worth spending a lot of time doing this. We've all heard the phrase, keep it as simple as possible. But the most important part is to keep it no more simple than it needs to be. If you over-engineer, you may gain a benefit, you've definitely got a loss. This is something that comes with experience, deciding when to stop. So, all those people who put their hand up, I'm going to disagree with you. Automation is not about time saving. Not only. Correct. And that's one of the first mistakes that people do make, is they focus on time saving. Yeah. So, we're looking at automation, we're thinking about automation and where to start. And thinking about time is a good place to start, but it's not the only place. Takes the most time is obvious. But if you focus on takes the most time, you'll be able to reduce it a little bit, and then you start again. And you're always looking at these things that are large in terms of time, but not necessarily in terms of impact. Another way to look at the things that you want to start with automating are look at frequency. How often are these done? So the axis on the left is important. Axis across the top of that table is important. If you do something 50 times a day, and each time only takes 20 seconds, that's still 1,000 seconds. And it's 1,000 seconds where every time you start the new task manually, you get an interruption in your thought process, your flow. So you're really unproductive. If you could reduce that to 10 times, or all you have to do is supervise and hit the button and the first one starts and you don't see it again until the end, Think of all the gains you could make in terms of just your personal productivity, your concentration. You can also focus on the things that are most annoying to you. These will usually involve people. It's true, just calling it as it is. But the purpose here, again, is to improve your personal productivity. Right? The things that are really annoying, if they happen enough and if they take enough time, are great candidates to automate. There's a subtle reason that I tend to go with most annoying first, and that is because the most annoying stuff is stopping me from doing other things that are more interesting. Now, that's a personal productivity thing. Organisationally, the most annoying things are the things that end up with rework, the things you have to go back and do again. All right, and there's a subtle hint here because that's a quality consideration. If you can avoid going back, if you can avoid having to retouch something, you get productivity and quality out the other end. This is good. Another place to look at automation is, where do I make the most errors? Because if I'm making errors and I can reduce the number of errors, the number of defects, the number of reworks, again, I've got a gain in productivity. I've got a gain in whatever process I'm running here. All right? And I'm probably going to get some other really subtle benefits like better security. All right? If I can generate rule sets for a firewall from a table of subnets, that's going to be a lot more secure overall than if I did it by hand every time. Because people make mistakes. And they do it naturally, and it's not intentional. But if we automate that, it's one less thing that you have to think about. It's one less thing to go wrong. Obviously, if it goes wrong, it goes really wrong. But hey, that's automation. If you're business driven, having a look at the tasks that have a more positive effect on revenue is really good because you can sell the time that you're using to automate to management. If we do this, we're going to get a higher revenue, or we're going to have less costs measured against our revenue. Engineers, systems people, the stereotype is we don't do business well. Well, guess what? We actually do if it's framed properly. It's an engineering constraint. That's all it is. How much money can we make? Right? That's an objective. It's not our money, but we're paid to do this anyway, so why not? Other ways to think about choosing where to automate first is choosing something that you're going to learn from. This could be a task that needs a new tool or a new type of tool in your environment. This is a reasonable justification. We need to do this anyway. It's on the list of things that we could do better. We'd like to learn a new tool. I'd love to learn how to program in Go this year. So maybe I should find something to do in our to-do list that actually requires that. Now, it may take a little bit longer to automate that particular task. But at the end of it, you have an automated task and new skills and understanding. That's a win. I've mentioned productivity a couple of times. Go for the tasks that are affecting your productivity. If you automate those, you now have time to, well, obviously do other stuff, but to learn more, to work with your juniors, to teach them, to learn new skills internally. You can do heaps and heaps of other things that you're currently blocked from doing because your productivity is, frankly, poor. Right? We all have bad days. I like to have less bad days. Now, I'm lazy, and I don't mean that in the I avoid all work sense. I mean that I don't want to do things unnecessarily. I'll do it once, I'll do it twice, I'll do it 3 times. Time number 4, I start to get annoyed because I can see a better way to do this. So I try to get just a little bit better, just a little bit. Once or twice a week, I find myself writing 1 or 2 line shell scripts. Now, not that 1 or 2 lines actually gains me a lot of actual time productivity-wise, but by encapsulating complex command lines in a shell script, it's effectively cut and paste from my history. What I'm doing is I'm saving my cognitive productivity. I don't have to think about exactly what command line I used last time to do this because I just put it in a shell script and I know where the shell script is, and there's probably more comments in my shell script than there is code. So I can go back and look at it and figure out exactly why I did something, which is really important. All of this ends up equality. The more you automate, the more consistency you have, the less annoyed you are, the less errors you have. And this is all about quality. You get things done faster. You get them done with more quality. Questions so far? Disagreements? Strong disagreements? Awesome. Finally, you're going to end up at a point of saying, well, yeah, but so what, Mike? Where do I really need to start? Well, I assume that you're all competent professionals. So I would ask you to answer this question. Where will you get the most value return for the least effort? It's not exactly low-hanging fruit, it's close. But it's about value and about you understanding where you can gain value from automation. Where would you get the most value for the least effort? How many people have used AWS before? Enough? Have you all heard of the Amazon Mechanical Turk? Yes, okay. For those who haven't, it's a service where you effectively put requests in, and those requests are handled, say a search or give me some information about some product. Those requests are submitted to the system and they're distributed to actual human people. Human people. And the work is done by somebody else. But your interface to this is Amazon. It's programmatic, web form. It is a form of automation. It's also really cheap. And perhaps your automation here is not about removing people, it's about just getting the job done. If people are in the loop, that's fantastic. If they're not, it also is fantastic. So some beginner's tips for you to take home to your juniors. Guess what? It doesn't matter where you start automating. You have a big bunch of, oh my goodness, any improvements are going to be worth it. So you get to choose. It doesn't matter. Kind of. What you want to do is you want to choose something that has a small scope so that you can actually see what's happening and understand what's happening. No side effects, very little chance of breaking anything. You can keep it in your head. You can do it with one person, right? Or perhaps a small team. Choose a single scripting language or a configuration language, documentation. Just choose 1 or 2 small tools that you haven't used before and start with this. You're trying to solve an automation problem, but you're also trying to solve a personal problem, a you problem. You need to get experience with these tools. You need to get experience with the flow of automating. And that's what this will do. Now, low risk is good because, as we hinted at earlier, if you get a big risk operation wrong, everything goes wrong. And chances are it'll go wrong better than spectacularly. You won't see it. You won't know about it until the process is finished. And by that stage, it's too late to recover. So be careful initially. But again, you're trying to build knowledge. You're trying to build confidence. Now, you are going to make mistakes. Mistakes are generally okay as long as you own up to them. So how do you know you've made a mistake? How do you know you've had a success? Cheat. Define your metrics. Define the way you're going to measure your automation success before you start. And choose simple things. How many developers were there? There's quite a few developers here. Everyone should be putting their hand up. Developers, please. Do you all know what continuous integration and continuous deployment are? Essentially, you check some code in, stuff happens, you build an artifact or an output, and that output gets deployed into production or into testing, however you're set up. If you're a developer, you submit your code. There are some really, really, really easy metrics that you can gain, or you can create, I should say, that show you the benefits of automation over time. Right, you've all heard of unit testing, so I don't need to explain what it is. How many unit tests do you have? That's a number. How many unit tests pass? That's a number. All of them, depending on how you set up your pipelines, yeah. How many commits are not allowed to proceed to deployment because of a failure in linting or in unit tests or in integration tests? That's a useful number. It's a measure of quality. It's indirect, but it is a measure of quality. And it's a measure of how successful your automation has been. In fact, your commits shouldn't have got to the point of even being counted after linting if you've got linting. Sorry, bad choice of wording there. If you're going to have a metric, your metric needs to be realistic. When you commit code, you should actually be running your linting on the desktop. It shouldn't even get into the pipeline until it's met one quality bar. So as your developers get more mature, they automate their local testing, that number will go down. The number of defects that are in the pipeline will go down. There are other metrics that are really easy to use. How much time do I spend running this task? You keep a diary for 1 week. Number of incidents, amount of time, and you automate that task. And you'll see a saving or you'll see a loss. Record how much time you spent automating. What you're trying to do here is just be objective. You're trying to get confidence again that you are able to automate things successfully in your environment. You need to have a baseline for this as well. And your baseline will obviously start at 0 for some metrics, or 100%, or however you scale it. As a beginner, you need things that are easy to measure. So don't try and make up complex metrics. Just things that are easy to measure. How many times did I run this script? Okay? Yeah, almost slipped there.
Yeah, but you're going to run that script more often than you would do it manually.
Right.
Which improves quality.
Yep, but how many times did I run the task before? Well, if I've measured originally, great. Okay, so here's a tip. If you automate something using a script, that script needs to have logging built in so that you can see when you triggered the script so that you don't have to manually count it anymore. When the script exits, the script should say, I'm exiting because, and that should go to your central logging. Just simple collection of these events. Now, if you're a junior, and even if you're a medium or possibly a senior, once you commit to something, you'll reach a point where you have to keep going. Don't stop. It's hard. It's really hard if you're a junior because there's so many distractions. But you need to finish that automation task. If you don't finish the first one or the next one or the one after that, you'll never finish any of them. Right? You need to get into the habit of just automating things as a matter of course. Now, as you do that, what you'll observe is a certain level of maturity developing. In the first case, you can do it, right? That's you sitting there doing something manually when you have to run this task. Second case is you can at least do it consistently. That means documentation, possibly some scripting, writing some puppet manifests to build a machine out consistently. Great. The next step is that you get somebody else to do this. Excellent, you're buying drinks after this one. After you've tested it with an individual, someone else other than you, because we all know that you shouldn't test your own code, make sure that somebody else can do it unassisted. Eventually, you'll have it to the point where the computer does it. You don't have to do anything. Maybe, submit a ticket and it all happens. And finally, you'll get to the point where you don't remember how it works. And at that point, automation has become an abstraction for that particular process. You don't know, and honestly, you don't care until something goes wrong. Now, the disadvantages of this are pretty clear, and in fact, they're pretty common with all abstractions. Abstractions hide detail. Sometimes that detail is actually necessary to understanding what's really happening. Sometimes. Generally, hiding detail is good. It allows you to compose things. It allows you to glue things together in ways that we're all familiar with because of Unix. Right? Has anyone ever thought about how Unix came to be so successful? Pipes. Pipes and file descriptors, yep. Sorry? And C, yeah. Well, the modern version of small things with pipes are APIs and microservices. They're very similar. And part of the reason we're using APIs and microservices so much is, I think, and this is an opinion only, but I think it's because we understand deep down that this is just another generation of Unix-like abstraction. It's kind of cool. So why do you automate? Well, these are all bad reasons. Okay, don't do this. Yeah, some better reasons, perhaps. We've talked about all of these: consistency, error reduction, personal productivity. But there are better answers. Because without automation, you can't scale. You just can't do it. You can't type fast enough. You can't give assurance about what's happening. All you can say is, well, I got a number out the other end. Yeah. Was there a person involved? Yes. How do you know that number is consistent? I don't. At least if you've automated, you have predictability built in. All right. There are some other answers. This is for the management people. Automation is about reducing technical debt, right? Because you wouldn't be technical debt if you'd automated it in the first place. And yeah, we've got more interesting things to do. There are a couple of places to start. These slides will be available at some stage after the conference. You can read these yourself. But I wanted to get to the interesting question. What tools should I use? Well, there was a very, very clever Dutchman named Edgar Dijkstra, and this is attributed to him. And for me, it resonates quite strongly. The tools we use have a profound and devious influence on our thinking habits and therefore on our thinking abilities. If we only use the one type of tool or limit ourselves to just that one tool, there's a very good chance that the solutions that we try to come up with when we're automating are going to be inefficient. It's not guaranteed, but there's a very good chance. If all you have is bash, can you scale out the provisioning of 10,000 Linux machines? No, probably not. If all you have is systemd, okay, enough said. And guess what? Because I'm me, documentation is a tool. It's a critical tool. Tools don't have to be scripting languages or configuration management or schedulers or orchestrators. Tools can be approaches and ways of thinking. Documentation is a tool. It's specifically a tool for automation because documentation is how you confirm your understanding of a process that you're trying to optimize. No document, no understanding. But still, does any of this help you? Yeah, probably not in terms of tool choice. So I can give you some hard-earned advice, and that is try to be consistent. Whilst you don't want to have just one tool for everything, you also don't want to have 50 different variations of the same type of tool. Try to keep the options small. It makes it easier to scale out use of the tools within your teams. If one person is the only expert for a tool in your team, you've got a weak spot. So finally, we get to yak-shaving. He's been talking about automation for the past 30 minutes. I want to see the yaks. There are no more yaks. There is another cartoon, though. I love this cartoon because this is what yak-shaving is really all about. Except it's not problems. Well, maybe. Yak-shaving is quite negatively portrayed. We talk about yak-shaving as something we don't want to do. Right? We try to avoid yak-shaving. Why? It's a waste of time. Right? We're not working on what we're meant to be working on. If you're yak-shaving, it shows that you're incompetent. That should have only taken 10 minutes. It was an easy fix. You've all heard this before. You've probably all said it to yourselves. When you go home at night, I don't know what I did today. I know I was typing all day. I know stuff got fixed, but I don't know what I did today. Because I was working towards that goal over there, and I can't do that until I fix this API. No. Okay, now I've got to update the documentation. Now I've got to generate the docs and send out a new version, update the changelog. All of these are things that I probably should have automated. But I was yak-shaving. If you are yak-shaving, this is evidence that you don't really understand the problem you're trying to currently solve. You don't have a true understanding. If you did, you should be able to go straight to the end solution. Now, this isn't necessarily bad. You're probably encountering technical debt. Or you might be procrastinating just a little bit. Or encountering politics. Damn, why didn't you give me that feedback last night, Rudy? The important thing about yak-shaving, though, is even if you don't understand how you're getting to the end, every time you shave that yak, every time you do one step, you're one step closer on a problem that already existed. You've solved something. This is why yak-shaving is important. We have to shave yaks because otherwise the problems can't be understood. We can't get close enough to understand them. There are bonuses besides getting closer to the problem. There are opportunities here. Don't waste the opportunities. If we're yak-shaving, we should be thinking that what we're doing is building understanding. We're not wasting time. This is what's going to allow us to make better tool choices and better automation choices. All right. And kind of funny enough, can you imagine having to run the first Unix systems and flip switches to just get the machine to boot? How long do you think that lasted? Probably about 3 months, to be fair. When you load up your IDE, when you load up your editor, think about the history behind that tool. Think about all the problems that were solved to get you to the point of being so productive with that tool. Without yak-shaving, we couldn't have got there. We couldn't do the work we do today We couldn't use the tools we do today. And honestly, we couldn't do the jobs that we all love doing. That's what yak shaving is. Thank you. Vragen dan bier. Questions? Comments? Disagreements? Yes, one disagreement from the back. Go away. Please.
There's missing a point. I think you should take into account happiness of people when automating.
Oh yeah. Hang on. Yep. I include that under sanity. Right? If it's annoying, it makes me insane and unhappy. But absolutely. Come and grab me later. We'll link in, and I will add that into the deck because explicitly calling it out is a good thing. I will add it manually though. Okay. Yes.
It's a great talk, but what I miss is when you start using it, I think it has to be started on education. So if you're on school or learning how to program, you also have to learn how to automate those things.
Yes.
And most schools don't do that. They learn you just how to program or how to...
Yes. You learn how to code and that's it.
Yeah.
So I was very privileged. I got to lecture at a university for 8 years. And one of the problems that I had with the course that we were teaching was that there was always this, every semester you had to learn a new language and you couldn't proceed until you'd learnt that new language, which meant that you needed to get to second year before we started things like shell scripting and automation of development processes and unit tests and all those kinds of things. And one of the things I'm proudest of is that we actually changed the curriculum and started to do more of that automation in first year. I totally agree. I couldn't agree more. We need to teach automation in conjunction with programming from day one. Absolutely. Thank you. Sorry. Give this man a clap. Thank you all.
Thank you. It was great to have you.
Ooh.
Great talk. Thanks.
Thank you. Stroopwafels.
Yeah. Yay. No Tim Tams.
No Tim Tams.